Welcome to today's webinar. The topic today is new features in Rfem 6 and Rstab 9. The features that we implemented in the last time, the last months, approximately the oldest feature in this webinar, maybe half a year old. I will display or show that features in a PowerPoint presentation and in the program. I will be the presenter today. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal software company. For instance, the German and English webinars, the Dlubal website, customer projects, and so on. Okay, my two colleagues will support me, but they can introduce themselves.
Hello, my name is Frank Vollstich. I'm responsible for quality management, and today I will answer your questions.
Hello, my name is Andreas Niemeyer. I'm responsible for the product engineering, and today we present you our new features in the program.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. For the attendees who take part in such a webinar the first time, you can show or hide the control panel with that arrow here and then enter a question here. And Andreas and Frank will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email afterwards, via email, an email with your answer. Okay, the other way is to watch the entire webinar and then email your question to info@dlubal.com. To the agenda today, the first point is new features in Rfem 6 and Rstab 9. I introduced general features. As I said, is a mixture between PowerPoint presentation and presentation of the features in the program. Then the second point, new features in add-ons and standalone programs. And the third point is prospects. Means that I introduce features, they are planned for the next year. Okay, then I start with the first slide and the first feature, node, line, and surface releases. It's possible to define transfer conditions between objects. You can release members, surfaces, solids, for example, and you can also consider nonlinearities, such as fixed if positive n or something like that. Okay, that feature I would like to show you in the program Rfem 6. It's a quite simple structure, a steel construction, and on the top of the steel construction is a concrete slab with an eccentricity. I click on it or double click on it, and I checked here eccentricity. And when I go to the eccentricity, you can see that is an automatically offset, and I defined that the bottom of the concrete slab is on the same place like the top of the steel structure, member number 18. This is member number 18. Okay, to see it better, I go to the navigator display, then solid model, surface is now filled, and this is filled including thickness. Okay, I would like to display it without the thickness. So the target is that when I assign a load in that field here, that this area of the slab can take off. Yeah, this isn't the case at the moment. Let's try that. I create a new load case in post load with the action category in post loads. Okay. And since it is a full slab here over 2 fields, I have to define a rectangular load left above, insert, loads, and then 3 rectangular loads is the feature that I use. So I select the slab. Okay. Then a quite high load, 20 kilonewton per square meter. And I define the edges. Okay, that's all. So, and I calculate the load case. And you will see that the concrete slab can't take off. I displayed the sections colored. So, and you can see that the slab don't take off here in this area. How to do that? With a line release. So, insert, special objects, and you can find the nodal releases, line releases, and surface releases here. Yeah, they act the same way, and I use it in this example. I use in this example the line releases, since they work simultaneously or similar. I select the lines. Okay, all the lines into place, and I release the surface number 1. This one. It's only one surface. And I have to define the line release type. Okay. In the first step, I release the use set direction, and I use this nonlinearity fixed if positive V set. That means if the load is in plus Z direction, it is fixed, but can take off if the load is in minus Z direction. Okay, let's try that. We calculate the load case again. So, and now you can see that the concrete slab takes off. But in that area, the beams act as composite beam because of the eccentricity of the concrete slab. At the moment, we have a deformation of 2.7 millimeters. And when I release the slab in direction X and Y, then we will get a higher deformation. Then the concrete slab lies loosely at the top of the steel structure. So in the navigator data, under special objects, you find the line releases, and you can double click on it, or you can search for the types for special objects, and you can double click on the line release type, and then the same dialog opens. Okay, then I release the concrete slab in Y and X direction, but I have to enter a small spring that the slab can't be moved. then it would be unstable. When it would be 0. Okay, we had a deformation of 2.7 millimeters. Now they aren't composite beams anymore, and that's why we get a higher deformation of 5 millimeters. Okay, then we turn back to the PowerPoint slide. Next feature, result difference to initial state. That is useful. Also this feature is useful, for example, if you would like to consider the soil safe weight as an initial state, in the geotechnical analysis. We showed that feature in the latest webinar about geotechnical analysis. You can find it on our website. So next features, small, but I think good features. The zoom with window with the right mouse button, or the animation of deformations. I showed it in the program. So if you click with the right mouse, then you can zoom in here. I don't use this feature because I have a scroll wheel, and I can zoom in and zoom out with the mouse wheel. I switch to the wireframe model. You can select objects by pressing, or more than one objects with the control key. I hope you see the plus on the cursor. Yeah. Okay. And with the shift key, you see a minus. I hope you can see it. And you can exclude it from the selection. So double click on an object. You can edit the object, or right click, you open the context menu. And if you select anything, and when you press the CLRT, the control key, then you can copy those columns here, and without pressing the control key, you can move them via drag and drop. Okay, that should be all to the mouse functions. Here under the load cases, you can animate the deformations, also with colored sections. So, okay. Then we turn back to the PowerPoint slides. Next feature, save as version. You can save different model states within a model. You can define an automatic save, and you can adjust the cycle. I showed it also in the program. File, save as version. And when you open the base data, also left above, then you can find the register history, and you can find that saved version. I've already some saved versions because of the German webinar. You can add comments, for example, a completed steel structure or completed model without loads, etc. Okay, and under options, above options, program options, you can find the automatic save function. And you can adjust the cycle. It's also possible to save after every calculation. Okay, then next features. Displaying result values on ISO lines. For example, for deformations, internal forces, stresses, and so on. I can show that also in the program. We change the view, set direction. So, okay. And when I scroll down to the ISO lines and the result values, then you can see the ISO lines and the result values. Yeah, it can be quite a quite good feature when you document pictures in the printout report. Yeah, the same is valid for internal forces and so on. Okay, also another feature I change to the isometric view is the perspective camera. It was wished by several users, and we implemented that. It was already there in Rfem 5. Okay, then next feature is the 3D mouse support. You can operate with your free hand. I don't have gotten 3D mouse, that's why I can't show that. Yeah, but I would like to mention that feature. And anytime you can find more information when you download the PowerPoint slide and then click on the link. At the end of the webinar, I show you where you can find the slides. Then creation of calculation diagrams. You can represent relationships between different results, for example, stress strains, internal forces, deformation, etc. I would like to show that with another model. A simple column fixed at the bottom, and on the left side in the navigator data, where are the calculation diagrams. I already created two diagrams. Now, for example, for the static analysis, the increment, maximum deformation, and you can see such a diagram. It's non-linear because I use the large deformation method. So that's for the static analysis, and this diagram for the stability analysis. I create another diagram that you can see the options on the horizontal axis. Yeah, there are different types, members, global deformations, member strains, etc. I use nodes, global deformation, UX, and the node at the top. And I use here nodes support forces, peaks, and the node at the bottom. And then you get such a diagram. Okay, that was wished by a lot of users. Then turn back to the PowerPoint slides. Changing node types. Yeah, you can adjust the type and location. I would like to show that also in the first model. Now, for example, for this node, when I double click on it, then you can change the node type. For example, from on member to standard. You can add supports, mesh refinement, releases, etc. And you can change the distance between the node or the two nodes. For example, I can change that from 50 to 20% and apply that. Okay, and the node has been moved. I undo that. Okay, then PowerPoint slide. Next features. Yeah, a quite powerful feature, the member type surface model. You can simulate openings in webs. You can consider the real stress distribution. And you can use it, use the member results in the add-on. And yeah, you can use it for castellated beams, perforated beams, beams with rectangular openings, Virandel trusses, etc. I would like to show that in another example. I've already prepared a single span beam. The cross section is an IPE 500. So, and I would like to add holes here, or openings. So that's why I double click on the member and I change the member type to surface model. And I select here member openings. Dialog was added, member openings, and I define the openings. Where are three reduction types: rectangle opening, you can see that here in the preview, the circle opening, and the hexagonal opening. Yeah, so such a typical castellated beam is displayed here in the preview. I select the circle opening. I start by 0.5 meter, and I would like to add more than one opening. 13 openings, and the offset can be absolute or relative. Now relative, then you have to enter % here, and I choose absolute. And the offset should be 0.5 meter, and the diameter 300 millimeters. Okay, I apply that, and you can see the circle openings. So, and right above, there's a new button, and you can switch between display surface model and the normal model. So you can see rigid members here that you can connect members, for example. If you want to consider such a model in your complete member model, the stiffness, for example, of such a member or something like that. So you can see that the load has gaps. I entered the load in the middle of the beam. And I would like to correct that there are gaps. In the navigator data, where are the loads? And you can see the new line load and the member load, and both are still connected. If I change the member load, the line load will be changed. So I double click on it. Then I select eccentricity, and under force eccentricity, I select the top of the member for the load. Okay, and now you can see the member load and the line load. And the line load acts on the line number 68. You can see that in the preview. And this line is line number 68. Okay, that's correct now. So then we can calculate or I have also defined an design situation. Now with only one load case, but I use that design situation. So, and now you can see, for example, the surface stresses, basic stresses, principal stresses, and so on. And if you want to do a real design, then you have to go to the base data and activate the add-on stress strain analysis. Okay. And I change the setting or the settings of the stress strain analysis. I select only the surfaces for the design. And now you can see also a stress ratio, the different stresses, sigma eq v max von Mises, for example. Yeah, that's a normal stress analysis. If you want to do a stability design, you have to activate the add-on structure stability, and with the eigenvalues, you have to define imperfections and assign that to the structure and do a stability analysis. But for such a stress analysis, we would be at the end. Okay, that should be all to that feature. Next feature is plastic hinges according to FEMA 356. And it's possible to create pushover curves with that feature. In the future, we will implement the new add-on pushover analysis. I will mention that in the prospects. Okay, next features, dividing surfaces with intersection lines. That's quickly to show. I create this simple rectangular slab. Doesn't matter what it for materials. Okay. Then I draw a line. So it's still one surface, but when I right click and then select divide surfaces with intersection lines, now I have divided it, and now those are two surfaces. Okay, then next feature, accessing the manuals chapters with the F1 key. It's also a powerful feature when you need help. I go back to the program. For example, that's the cross section, and you can go to any chapter here or any dialogue. And when you press your left at the bottom, the help button, or you press the F1 key, then it moves to the stress points, to the chapter that is connected with the dialogue. Okay. That's all to this feature. Next feature, intersection of curved surfaces and solids. Where a new surface type, it's trimmed for intersections of, for the intersection of curved surfaces, for example, for pipe penetrations, twisted openings, and so on. And for the solids, there are two new types, hole and intersection. And you can use it, for example, for complicated construction, pit shapes, perforated solid shapes, and so on. I would like those two features in the program. I start with the second feature, with the solids. So next model, manhole is the name. I created 4 different solids. I can open them in the navigator data. 4 cylinders. I use different materials, the concrete for the manhole that I would like to create, and those solids are from steel. And if I want to use Boolean operations and subtract those solids from this solid, I have to select the 3 solids, then right-click and edit the solids. And I select the solid type hole. Okay. And now the 3 solids are subtracted from the first solid, and that's the manhole with openings for pipes, etc. Only a simple example to show that. And with that button here above, you can switch between different display options. Okay, next model for the intersections. It's an empty model. I draw 2 lines. So, okay, such a crossing. And I enter pipes. The thickness of the pipe actually doesn't matter, but I change it to 5 millimeters. Okay. And select under the dialog pipe the radius, or define the radius 20 centimeters. Okay. The first pipe is created. So, and with enter, I go back to the dialog and I define a radius of 15 centimeters. Okay. So there are 2 pipes, but they are not connected. When I select them and with a right mouse click, I open the dialog, and under the surfaces, you can find the options: create intersection, divide by intersection, and create openings. I select the middle feature, and you can see now there are intersections with different components. On the left side in the navigator data under surfaces, you can find the different components, and they are trimmed. I click through the single components. So, and I select those components that we don't need. With the Control key, I can select more than one surface. This one, not this one, but this one, and not this one. Okay. And I delete them. Okay. And now we can take a look through the pipes. and that's the intersection line here, NURBS line. Yeah, and the pipes are now connected. Okay, then we turn back to the PowerPoint slides. Yeah, moving the clipping plane is also a good feature to evaluate your results. I go back in the program. So yeah, it's good to show on such a solid model with results. And under guide objects in the navigator data, you can find the clipping planes. And by right click, I can create a new clipping plane. Yeah, there are different types for the clipping planes, 3 points, and angel, and so on. I like the offset because I only have to select 1 point in the model and define the plane. XZ, for example, and I press OK and set active. And then that's the new feature. You can move the plane with such a point here on all edges. So, and for example, you can copy that clipping plane and only change the plane. So then you've got the same feature. Yeah, as I said, is a good feature to evaluate your results. Okay, then to the next feature. Assigning types in the graphic. Yeah, you can assign nodal supports, effective lengths, line supports, and so on. It's a longer list. You can find the longer list when you click on that button here. Yeah, I can do that. It's a longer list. Okay, then note to the PowerPoint. Okay. But I would like to show that feature, for example, with nodal supports. I go back to the program. For example, in the first model. For example, when you want to add such a support to different nodes, you can find the types for nodes, nodal supports, and then by right click you can select assign to nodes graphically. Right? For example, you can add them here quickly. Yeah, it is a good feature, I think. Maybe better for other components such as effective lengths also. Okay, next feature is the interface with Autodesk Revit 2022. Yeah, the bidirectional data exchange is possible. You can transfer members, surfaces, hinges, supports, loads, and so on. And you can update the model in the other program. Okay, that was all to the general features in Rfem 6 and Rstab 9. Now I would like to introduce some features of the add-ons and the standalone programs. Not in the programs, only in the PowerPoint, because it's not interesting for everyone. Our wind, the freely adjustable wind permeability for surfaces is implemented or has been implemented. That's, for example, for permeable scaffolding, dust curtains, mesh structures, and so on. Then use the editor for mesh refinement control. Then other new features are the load factors for zones, the point clouds, new or auxiliary objects, and so on. In the webinar 2 weeks ago, we presented all those features. And if you click on that link, you can watch the recording and see all the new features. Our section, we are also interesting features. You can create elements automatically from an DXF file, or you can use DXF template lines as center lines of an element with a defined thickness. For example, when you see that cross-section here, imagine you have center lines as in DXF, then you import the center lines and only define a thickness of, for example, 2 millimeters. And then, with one click, such a cross-section is created. Then new feature, plastic unit stresses according to simplex method, and the creation and import of blocks in our section. And the creation is also possible via JavaScript. Our section and steel design add-on. New is the mode shape, or the graphical output of the mode shape for distortional and local and global buckling. Also for our section cross sections. It's also a feature of our section for library cross sections. New in the steel design add-on is the designing of code-formed steel members according to EN 1993-1-3. Okay, and it's valid for code-formed sections from the library and for general code-formed sections from our section, but not for non-perforated sections. Then concrete add-on. There are also powerful features. For example, the automatic layout of surface reinforcement. You can define, for example, here automatically for the diameter, define, for example, minimum and maximum diameter, and the program determine the optimal diameter of the reinforcement. And the same is valid for the rebar spacing. Then another feature is the multi-editing of member reinforcement. You can define the options for the concrete design for more than one element. For example, members and set members. Use also the detailed results in graphic or the punching shear of foundation plates. Then new in the steel add-on or steel joints add-on is the connection of rectangular hollow sections. You can see that on the right side. And they are connected via welds. Then there are new components, end plate to plate, the general weld, and the fastener. Means you can assign a general positioning of screws. And another feature is the copying of one or more components. That's a feature what we already showed in the latest webinar of the steel joints add-on some months ago. You can find it also on our website if you are interested in the steel joints add-on. Then Really new is the design of CLT panels and the multi-layer surface add-on. You can perform an ultimate limit state design and serviceability limit state design, fire protection design. You can use it for floor slabs, deep beams, and so on. And you can treat singularities, and also a fastener design is possible. We would like to show all those features in the webinar Modeling and Design of CLT Panels in Rfem 6 on the 19th January the next year. Bastian Kuhn will present it, and you can already register when you click on that button here. And the last feature of the add-ons and standalone programs is the improved segmentation for deformation analysis. It's valid for, or you can use it in the timber design and concrete design add-on for the automatic segmentation for deformation limits, cantilevers and single span beams. Okay, that should be all to the features in the add-ons and standalone programs. Now we turn to the last point for today, the planned features. We will update the interface with Autodesk Revit to the version 2023. Then we will implement the interface with P-class structures. Then it's also planned to implement the load transfer. You can transfer the load from another model, and both are digitally linked. Means when you can transfer the support reactions to the next model and assign it as load of the structure. And if you change anything in the first model, it will be updated in the second model, for example. Okay, also the load transfer for the building model is planned. You can transfer loads within a building and then calculate or can do a 2D calculation, for example, for the slab or the wall, etc. Then for the dynamic analysis is new or will be new, the time history analysis for accelerograms and the pushover analysis. Then we will provide the cloud computing. For example, for larger models, you can use external computation servers such as MS Azure or something like that. Okay, then new is the consideration of precipitation quantities. For example, water pocket, or you can consider the load of rain on a flat roof structure, etc. Then for the concrete design is planned to implement the nonlinear concrete analysis and the fire resistance design for concrete. Then we will integrate the foundation design and the glass design. And in the add-on steel joint, we will provide the design of circular pipe sections. Then for membrane structures, it's planned to add a new add-on, cutting patterns, and a general feature for Rfem 6 and Rstab 9 are the guidelines. Those are also planned. And in our wind will be an interface for the import of empirical wind tunnel data. You can use the wind tunnel data for your calculation in RWind. Yeah, that's only a selection of planned features. Also, what I showed that were only the, I think, most important features that we implemented last time. You can find all implemented features in your Dlubal account. I would like to show my account. Then you can find, if you start the page, you can find my messages, and under development, you can find, for example, for Rfem 6, all the features, and you can select, for example, timber design, all the features, or steel joints, or something like that, steel design, for example. Now, I mentioned the cold formed steel design, but there are also other features. For example, the design according to British standard. Okay, that should be all for this webinar. I would like to show where you can find the recording and the PowerPoint slides and the models on dlubal.com, and under news and events, you can find our webinars. This is today's webinar, and in the next year are already some webinars planned. The FAQ, the regularly FAQ webinar, the CLT webinar, and other webinars. Okay, that's today's webinar. And in the next days, you will get an email with your certificate and your attendee certificate, and with a link to that page here, and you will find the recording of today's webinar here already, as you can already find the presentation slides here and the provided models. Okay. That should be all for today's webinar. I thank you for your attention. Thanks to my two colleagues for answering your questions. Maybe a last hint: when you leave the webinar, there's a small survey. It takes you only 1 minute. Just score us. It's quite important for us. Note that the worst score is 1 and the best score is 5. You can also answer some questions, your wishes for future webinars and so on, but you don't have to answer them. Well, it's not necessary to answer the questions. You can leave it empty or enter a minus or something like that, that it takes not too long for you. Okay, I wish you Merry Christmas. I hope we meet each other in another webinar, or in one of or more webinars in the next year. And bye-bye.